Alright, so today we're going to be taking our scientific notation and start to do operations with them. And I heard yesterday that we're beginning, you're kind of comfortable with operations, but we need to kind of clean it up a little bit. And yesterday we also talked about taking a trick, taking your standard, can you put this at the top of your paper please? Here's a standard number line. And the standard number line to the right is positive, to the left is negative. What if we're going into scientific notation? It is opposite and not, remember. To the left is up, to the right is up. Okay, now, I put the problems from your work today because it's very, very simple. So let's talk about what we did for number 1. We had 3 to the 5th times 3 to the 7th. We don't change the bases, right? And it became 1. 3 to the 12. Okay, so let's take a look at number 1. You have 10 to the 5th, you see where I'm focusing right here? And you have 10 to the 7th, and you're multiplying them together. Same concept, we don't change the bases, so it's 10 to the what? 12. 10 to the 12. So write that down, please. Now, what's new for us is that we have to just straight out multiply their coefficients. Okay, that's just regular multiplication. So bring your numbers up to the side of your paper. That's 3.2 times 2.1. And I always like to multiply without decimals. Multiplication. So we have 672. And then I heard a lot of you say go back in 2 spaces. Because of our decimals right here, so we have 1, 2, 6.72. So that number is 6.72 over here times 10 to the 12. Now the last thing I need for you to check, is this in scientific notation? Do you only have 1 digit in front of your decimal? And be a 0. Then we are good to go. Just our answer. So the same thing as the previous night, except you really have to watch, don't combine the bases with each other. So if you think back to, oh, we did this in the warm-up, you know, I know how to do this. Alright, number 2 on the warm-up. We talked about that today. We're always, with scientific notation, we always subtract into the top. So our concern is not to get a positive or negative exponent. Always get a positive. So in our answer here, then it's 3 to the left. Alright, so that being said, if that was our problem, we would continue on further. We would simplify down to 1 method. But for scientific operations, we're going to take that concept as well. So again, you're looking at these base with the exponent, base with the exponent. And we are going to subtract that into the top. Now be really careful because we're subtracting a negative 3. Positive what? It's adding, so 8 plus 3? 11, positive 11. So it's still 10 to positive 11.
On the top one, it is 3 to the negative second, and we multiply the 2 thirds together. It would be a negative when we don't multiply.
We're not, yeah, I did this to show you to be clear. But, yeah, so this one simplified out to 1 minus x. It has to be a positive. So remember, negative exponents don't have anything to do with making some positive or negative. Negative exponents are placed. Negative exponent sent things to the bottom, negative exponent sent things to the top. Now, how would this answer be negative? It would have to have a negative in the front of it in order for this whole answer to be negative 1 method. That's where the negative would have to be completely unnecessary. But are you still okay with going down the scientific notation right here with always press the top? Okay? Alright, now, just like before, we have 2 regular numbers. And separation between division. Okay, so I have 85 0.5 going to 3.4. Okay, first of all, can I divide with decimal? No, so if I move this guy over 1, where must the 3.4 move over? 1. Now let me rewrite him. He's really 85 going into 34. Does he go into 34? No, so let's put down a decimal. Let's put down a 0 up there to say no. Let's bring another 0 right there. So 85 going to 340. Let's think about a rational number that we could choose. 85 is pretty close to 100. 340 is pretty close to 300, 100 to 300. Where is it starting from? 3. Okay, now, with 3, 5 times 3, would that get us to a 0? No. Maybe let's try 5 times 4. 4. Let's try that. We can try 2 as well. But 100 times 2 is only 200. Pretty low. So we're going to try 4. That's using our number sense skill. Using a 4 right there. Ooh, check that out. 4 times 80 is 320. 4 times 5 is 20. 340. Exactly right there. That's good. Done. Okay, so I'm going to write that answer over here. 0.4 times 10 to the 11. Oh, I have an issue with this. It's coming.
So it's not a full number. It's not the number before the.
I want to start with that word. It is a whole number.
I mean, not a whole number, but it's not a
Number before being 0. Correct. It has to be digits, single digits, between 1 and 9. So that's an issue for us. So here's how we're going to correct it. Instead, I want to take my decimal to the right, one place, and make it 4.0. But if I move it to the right one place, I need to change my exponent over here. So look back up at the top, or in notation, so you're down here. If you move it to the right, that means minus. So I'm going to subtract 1 from the exponent. Right there. If I move to the right, subtract. Left, add. So now it's 4.0 times 10 to the 10. We're going to practice that skill on the next 2 as well. So we can use it. Let me it would have been more effective just to rewrite it now. Yeah. Let's go to our next problem. We're going to practice doing that. Where the decimal goes. By the way, I also like the words right, subtract. They're alphabetical. Left and add. Those are pretty close alphabetical. A is closer to L than R. So that helps you remember. Left, add, right, subtract. Left, add, right, subtract. Left, add, right, subtract. Okay, so let's try to keep that in mind. So I have 25.2. Where does that decimal need to go? One to the left. The left. Okay. Look back here. Left means to add. We want one place. So I'm going to add 1 to that number right there. So here's our final answer. 2.52 times 10 to the negative 3. So tonight, when you're doing operations, we'll be really careful because some of them may look like they're the final answers. They're not. They're not. Number 4. Just curious, where do we want that decimal to be? We want it to be in between spaces. Okay. How many spaces do you get? In what direction? And right means to subtract. So we're going to subtract 3. Now I have 3.72 times 10. Careful. See? Negative 7, negative 3 more. Negative 7. Oh. I will teach you this word. I will teach you.
We're up group. Group. Woohoo! Now we're gonna move all together. Yay! All right. So this next guy is now go back to the beginning of the year. Remember how often we went through our labels like this? And I said 3 apples, 2 apples. How many apples?
5 apples.
Did you ever change the label?
No.
No. So we're not going to change the label today as well. Our label is sensitive. But it's sensitive. Could you do 3 apples plus 2 bananas? No. So what does that mean for us today? Our labels have to be the same. Our scientific communication has to be the same. So add and subtract, same label. See the comparison? Alright, so look at our labels right here. I have 10 to the negative 6, negative 10 to the negative 6. Apple, banana. So we can change it. Okay, so we can do negative 5 and turn it into negative 6. Or we can take the negative 6 and make it different stuff. Just think about it. First one, or do you want to choose the second one? First one. The first one's a great choice, and I like that you picked the first one because it's minus. So I thought we're going to get a bigger number over here. So what do we have to add to subtract negative 5? Subtract 1. That's 1. And going to our chart, what does subtracting 1 mean? What direction are we going? The right. So we're going to do the right 1. See how this helps for us? That's 61. Is a bigger number to subtract. 25 times 10 to the negative 6. We're going to subtract 3.98 times 10 to the negative 6. Now do I have an apple subtracting an apple? Yes, now we can subtract it. Now you focus on your numbers. Now, you guys can take this over to the side and do your long-term subtraction. Or I want you guys to think about this. This is almost subtracting 4. Take away 4 from 16. 57. Now bring the decimal back up to 85 plus 2. Now, if you don't get how I did that, then just take it to the side. And just do your long hand. And then do I change the label? No. Okay, so we still have apples, so it's still 10 to the negative 6. Done? No. No. Why no? Okay. How many digits? 1. So more. What direction do I do this? 1 to the left. What does left mean? Add. So add 1, so do 1 space. What's the final? Perfect. Yes. Why you that? You have to go to part. Are we looking at step 1? Yeah. Why we have to? Yeah. To negative 5 to negative 6. Yeah. No, but if you do like we did 10 to 6 absolutely correct. I want you to think that's what you can do in addition. You can only add like that. In multiplication, and you multiply together. Yeah, that one, you just combine it together. Oh, that's our previous. You don't worry about multiplication. But when you're adding, subtracting labels, so very important. Yeah, I'm really glad you asked that. So let's go to number 6. Come back. Okay, this is combining some of our previous sounds as well. How many of you pause? So, centimeters and millimeters. So the phrase with me, ready? Okay, it was a thought. 2. 3 to 1 level. Write it on the center paper. Where does centimeters start? At the C. Okay, and where does millimeters start? So what direction are we going? Right. 1 to the right. So go back to what we have. If we move 1 to the right, what are we going to do? Subtract. So here is our original right up here. You see it? Here. And we are going to subtract 1. So we're going to move to the right one and make that millimeters. Okay, so we're going to have 5, move to the right one, 50.8 times 10 to the how many? -2 minus 1 more. -3 millimeters per meter. So now we are millimeters to millimeters. That's a good first step. Second step, it says 1.5 years. We know how many weeks. How many weeks? 12.
Oh,
Closer. 57. 3.5. Lower. 54. 52. All right. 1 year is going to equal 52 weeks. What is half a year going to equal? 26. What is 1.5 years going to equal? 78. 78. This is a regular number. Now, if this grows 50.8 per week, what we have to do with that number to say for multiply it. Good. Now, what are we going to multiply this 78 to? Look here. Which number are we going to multiply? 50.8. That's the number because that's the coefficient. Times 78. Take it to the side. Long hand. Take the decimal and I'll put it on it right now. And 78. Mark it out. A rational answer, 500 times 80. That should be pretty close to. Oh. So go back to what I was saying. I just want to make sure that you're using good estimation skills. This is close to 500. This is close to 80. What is 5 times 8? 40. And how many zeros do I have? 3. Okay. Is our number without decimal there? Is that close to 40? 39. Okay. So do we have a reasonable answer? So put the number sense right there as well. So we okay with the 1 decimal place because it's 50.8? Alright, so let me pull my answer down here now. So this is 3,962.4 millimeters per 1.5 years. Now, my only issue. Right. Not a second. Where's the zero? 3 times to the left. 1, 2, 3. And left means and. Okay. Ooh, I forgot my. Okay, so left 3. So we're going to add 3. Ooh, what's negative 3 plus 3? 0. What's 10 to the 0 is? 1. We don't even need it. 3.9624 millimeters. Every 1.5 years. Okay, let's use a good number sense. No, let's use hold on, let me use number sense and then we go. This is about a meter. How would I estimate? How would I draw? of the start. If I wanted to say, fine, what can I start to do, like, take this down to right sides, so you know what's so I want to proper size. So let's go back to what you said. You said on the yardstick, which is here, 1 meter, and we have 1, 2, 3. So you said it'd be 1,000. So here's 1,000 millimeters. Okay, so you want to break that in the middle. So you're saying here's 1,000 millimeters, 500 millimeters. How many, if I wanted to go down to hundreds, how many spaces is approximately? 4, 4, 2, 3, 4, 100, 200, 300, 400? 5. All right. Your homework is on the board to the left. Finish that up.